Each individual action potential is a separate all or nothing event. That means that an action potential either happens or it doesn't happen, and our action potentials cannot be added together, so they cannot summate. So each action potential is its own separate all or nothing event, and they cannot summate. So they can't change in strength by adding two action potentials together, and they are completely separate events. Action potentials are separate all or nothing events because of refractory periods. There are two refractory periods in an action potential. There's the absolute refractory period and the relative refractory period. In the absolute refractory period, this is the period of time following stimulation during which no additional action potentials can be evoked. So during the absolute refractory period, no additional action potentials can be evoked. So you can't infringe on this absolute refractory period. The absolute refractory period corresponds to the opening of those voltage-gated sodium channels and their inactivation. So in other words, when those voltage-gated sodium channels are open, another action potential cannot be initiated because those voltage-gated sodium channels that open during depolarization are already open. So in our absolute refractory period, this is the period of time following stimulation during which no additional action potentials can be evoked. This corresponds to the opening of voltage-gated sodium channels and their inactivation. In other words, during this time, those voltage-gated sodium channels are already open, causing that cell to be depolarized. So therefore, if another action potential tried to come in and tried to open those voltage-gated sodium channels, they're already open. So another action potential cannot be initiated during this time period. Because of the absolute refractory period, each action potential is a separate all or nothing event. The second refractory period is called the relative refractory period. So during the relative refractory period, this is the period of time following the absolute refractory period. During the relative refractory period, another action potential could be initiated, but it would take a greater than normal stimulus in order to elicit another action potential. So the relative refractory period follows the absolute refractory period, and it corresponds to the period of time when you would need a greater than normal stimulus in order to elicit another action potential. The relative refractory period is when most of those voltage-gated sodium channels have returned to resting state, but some of those voltage-gated potassium channels are still open. So during our relative refractory period, this is really corresponding to the period of time in which most of the voltage-gated sodium channels have closed, but a lot of those voltage-gated potassium channels are still open. So if the relative refractory period corresponds to the period of time when voltage-gated potassium channels are still open, that means that this neuron is still losing a bunch of potassium ions. So we're losing a bunch of positive ions. That's causing the membrane potential to become much more negative, right? So it's repolarizing and then hyperpolarizing. So during this time, another action potential could be evoked because those voltage-gated sodium channels are back at rest. However, the membrane potential is very negative. So it's going to take a greater than normal stimulus in order to open enough voltage-gated sodium channels in order to reach that threshold of -55. So if you've got a bunch of voltage-gated potassium channels still open, a bunch of positive ions are leaving. That means the cell is repolarizing and then hyperpolarizing, so it's actually becoming more negative than the resting membrane potential of -70. That means that if another action potential were to come in, it would activate voltage-gated sodium channels to open, but it would need more voltage-gated sodium channels to open than normal because you have to go all the way from -90 to about -55 at threshold, as opposed to just -70 to -55. So during the relative refractory period, we're going to need a greater than normal stimulus to elicit an action potential.